A body of mass m is taken from the Earth's surface to the height equal to twice the radius of Earth. The change in potential energy of body will be. So according to this question, it is given that if you are considering an object which is on the surface of Earth, and this object is taken from here to a height which is equal to twice the radius of Earth. So this distance we can take it as nothing but 2r, and this distance is the radius of Earth. So our aim is to find out the value of change in potential energy. This we can take it as a final point, and this we can take it as initial point. Now we can write the equation for its change in potential energy. So the value of change in potential energy is final potential energy minus initial potential energy. So you can write this final potential energy is nothing but minus of G into M divided by, need to write the actual gravitational potential energy, not mgh. So this distance from here to here, we can take it as nothing but 2r plus r, which is equal to nothing but 3r. So this is final potential energy minus initial potential energy is minus of gmm divided by, when the object is on the surface, its potential energy is minus gmm by r. Now we can write the value of this change in potential energy. We can take this gmm by r as common. Remaining thing is minus of 1 divided by 3, minus we can write as it is plus. So we can write this change in potential energy is equal to gmm divided by r into 1 minus 1 by 3, which we can take it as nothing but 2 divided by 3. Now to write the answer in terms of given option, just multiply it with r and divided by r. Then it becomes something like gm divided by r square into m into r into 2 divided by 3. So that's gm by r square. We can take it as something but acceleration due to gravity on the surface. So we can write as m into g into r divided by 2mgr by 3 will give the value of its change in gravitational potential energy.